Hello everyone, I welcome you in this video lecture, and in this video lecture we will study what is the minor of any of the element of the matrix and what is its cofactor and what is their difference, and then we'll try to find the adjoint of a matrix. So let me write the general 3 by 3 matrix, and its element would be A11, A12, A13, A21, A22, A23. Because it is second row, so here first subscript representing the row number, it is 2, and this second subscript represents the column number. This is column number 1, this is column number 2, this is column number 3. Now writing the third one, A31, A32, A33. So I have taken 3 by 3 order matrix. Fine. So now we will try to find its minor. Let us say minor of A11 of this element. For this, to find the minor, and say this is represented by capital M11. This is leave the row of A11. This is row of A11. Leave it, and the column of A11. Leave it. The rest is A22, A23, A32, A33. So this will be the minor, and you know how to solve it. It's very easy. You will go up. So this will be A22, A33 minus A23, A32, and similarly other minors could be determined. For an example, minor of A22, what it will be? Leave the row of A22, it is second row, so leave this second row, and column is 2, second column, so leave these 2. So minor of, if I say A22 is M22 is A11, leave this A13, A31 and A33. Similarly, other minors could easily be determined like M12, M13, M21, M23, M31, M32, M33. So this A13, A21, A23, A31, A32. So that's how you calculate them. A32, A23, 21. So these are 7 minors you can easily calculate. Now we'll find cofactor. If I say cofactor of A11 will be on the same lines, leave this row and this column, first row and second subscript represent the column, the first column. So first row, first column, leave them and write A22, A23, A32, A33. Fine. And here also write -1 raised to the power 1 plus 1. So you know -1 raised to the power 1 plus 1 is -1 square. A22, A23, A32, A33. So minus 1 square will be 1. So this will be positive. A22, A23, A32, A33. Similarly, if we determine cofactor of A12. So what will be the scenario in this case? A12. First subscript represents the row number. Row number is 1. Column number is 2. So leave this row 1 and column 2. Rest elements are A21, A23, A31, A33. A21, A23, A31, A33. And besides that, since it is A12, you will put minus 1 raised to the power sum of the subscripts. Subscript is 1 plus 2. So this will be minus 1 raised to the power 3, and rest will remain the same. Similarly, you can calculate cofactor of any of the element, and this will be minus A21, A23, A31, A33. Similarly, you can calculate minor of other elements also. Like if I calculate minor of A31 or A32, it's a cofactor of A32. It will be minus 1 raised to the power 3 plus 2, sum of the subscript. It is important. Now leave 3, column number 3, row number 3, and 2, column number 2. It will be A11, A13, A21, A23. So this will be minus 1 raised to the power 5. This will be A11, A13, A21, A23. So this minus 1 raised to the power 5 is minus. So this will be A11, A13, A21, A23. So this is cofactor of A32. And say these cofactors are represented by, say this is represented by capital A11, and this is represented by capital A12, and this is represented by capital A32. Fine. And so on. You can calculate other cofactors and the minors also. In minors, the basic difference is that you don't include any of the sign, but in cofactor you also have to give the due consideration to the signs, and signs run upon minus 1 raised to the power sum of subscripts. If I take example, let us mark an example. Okay, say 1, 2, 3, 1, 1, 1, 2, 2, 0. Now if I say what is the cofactor of A11, this first element, or A11 is equal to cofactor of 1, which is position number A11, which is nothing but minus 1 raised to the power sum of subscripts and column and determinant. Leave first row and first column. What is left? 1, 1, 2, 0. And you know this will go down, this will go up. This will be minus 1 raised to the power 2 is 1. It will be 0 minus 2 is equal to minus 2. So this will be capital A11. And if we are required to find the cofactor of 3, 3 has position first row and third column. So this has position A, first row, position of 3, first row, third column. A13 is equal to cofactor of A13 equal to 3 is equal to, what it will be? So let me write it here. Minus 1 raised to the power sum of subscript minus 1 plus 3, and here determinant 3. 3 falls in the first row and third column, so rest are 1 1 2 2, 1 1 2 2. So this will go down, this will go up. Minus 1 raised to the power 4 is 1. It will be 2 minus 2. This will be 0. Therefore, A13 will be 0. So similarly, you can calculate other cofactors of the remaining elements. Like of 0, you can calculate what it will be. It has got third row, third column, so it is A33. So minus 1, 3 plus 3, leave this row and this column, we are left with 1 2 1 1. So what it will be? 1 into 1 is 1, and will go up, this will be negative, so this will be minus 2, this will be minus 1. So this will be the cofactor of this one. So in this we have studied about minus and cofactors of the elements of the matrix and determined the cofactor of the matrix by taking some suitable example. And minor is simply by leaving the row and the column in which the element is present, the remaining element, writing the remaining element in the determinant sign, and after taking determinant we will get the minor. And in minor we don't prefix any of the sign, unlike cofactors. Okay, in cofactor we do include the sign, which is the minus 1 raised to the power sum of subscripts. Okay, and that is minor and cofactor. So to find the adjoint of a matrix, we will require to find the cofactor of each and every element of the matrix, and then we'll form the matrix of the cofactors and then take its transpose. So before doing this, we will study what is transpose of a matrix. So now we'll study what is transpose of a matrix. So transpose of a matrix, like A matrix transpose, is denoted by prime sign, and some books also use AT. AT stands for transpose of A. So this sign is called prime sign. Okay, so this is the symbolical representation of a transpose of a matrix. So, and what is its meaning? Transpose of a matrix, let us say we are given a matrix A 1 2 3 1 2 1 3 3 3. So this 3 by 3 matrix is given and we are required to find A transpose. So what is the meaning of A transpose? We will write the rows and as columns and or columns as rows. Now the first row in this is 1 2 3. So this will become the first column of the A transpose matrix. So first column will be first row of A. First row of A is 1 2 3. So first column will be 1 2 3. Second row is 1 2 1. It will become second column. So 1 2 1. Third row is 3 3 3. So it will become third column. So this is the transpose of A. It is simply interchanging the rows, and columns of given matrix A, say. Okay, so by simply doing the interchanging of the rows and columns, so we can get the transpose. Like we do another transpose of a 2 by 2, simpler, we'll take some simpler, 1 7 8 0, and we are required to find its A transpose. It is represented by A transpose, or it is also represented by AT, A prime or AT is equal to. Now I'm going to make the rows as column. 1 7 is first row, it will become the first column. 8 0 is the second row, it will become the second column. So this is again 2 by 2. Or we can also see otherwise 1 8 is its first column. Now this is first column, it will become first row, 1 8. 7 0 is now second column, it will become the second row. So rows and columns have been interchanged. And we also know one another result, that transpose of a transpose, like A transpose, we further take the transpose. So in this case we are taking transpose of this matrix again. So first row is 1 8, it will become first column. Second row is 7 0, it will become the second column. So transpose of a transpose matrix is nothing but it is 1 7 0 8 0 8 0. It is a matrix itself. So it is important result that transpose of a transpose matrix is the matrix itself. So we have studied here the what is transpose of a matrix, and it is simply interchanging the rows and columns of the given matrix, and it is denoted by A prime or A transpose AT. So by simply writing the rows in the given matrix as columns of the transpose matrix, so simply by doing this we can obtain the transpose of a matrix. Now we will learn how to find adjoint of a matrix. For that we will be needing to find the cofactors and taking the transpose, so that will help us to find the adjoint of a matrix. So adjoint of a matrix we will be doing in the next video lecture, and I hope that in this video lecture you will be able to understand the procedure to find minor and cofactors of the elements of the matrix, and third one you will be able to understand what is the idea of a transpose of a matrix. So that is all I have from this lecture. In the next video lecture we will be studying about what is adjoint of a matrix and how to find it. So that is all I have from this lecture, and if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.